Find the derivative of y equals the square root of the quantity 8x minus 4, then evaluate y prime of 5. Y here is the square root of an entire expression, 8x minus 4. In order to take the derivative, we're going to need to rewrite that root as a fractional exponent. It's over the entire expression, 8x minus 4. It's raised to the first power, but then square root, or second root, so 1/2 power. The derivative, y prime, which can also be called dy dx, is found by the outermost function being a power function, the power rule. We'll bring the 1/2 down. We'll leave the entire inside alone, and then subtract 1 from the power, so that'll be 1/2 minus 2/2. And then we multiply by the derivative of the inside to complete the chain rule, since the derivative of the inside will not just be a 1, but the derivative of 8x, which is an 8, and a minus 4, which is a 0. We have an 8 that multiplies the entire expression. Now, since everything is multiplied, the 1/2 and the 8 can move together and multiply, and that will give us 8/2, and we will have 8x minus 4 to the 1 minus 2, which is negative 1 over common denominator of 2, negative 1/2. The 8 and the 2 can divide and become a 4. Because we have a negative exponent, that can move to the denominator and become a positive exponent. So y prime will be, the 4 won't move, but the 8x minus 4 will move to the denominator, become a positive 1/2 power. The positive 1/2 power can be rewritten as a square root to the first power, so just the square root of the quantity 8x minus 4. There's our derivative y prime. The next thing is to evaluate y prime of 5. Y prime of 5 means to plug a 5 in to each of the x's, and that will be 8 times 5 minus 4 under the square root, all of that underneath a 4. So we have 4 over the square root of 8 times 5 is a 40 minus the 4. So 4 over 40 minus 4 is 36 under the square root. Nicely, 36 is a perfect square, so we can take the square root of it, and this will result in 4 over 6. And 4 and 6 can reduce by 2, and that will give us 2 over 3.